We would like to focus on the additive manufacturing workflow based on the software for the additive. So therefore, the first point is that companies have their typical way of workflow starting at the designing, to have models, the traditional way, and then for over to the to get the files 3D printed, they need to be pre-processed, to prepare the files for so that they are convenient to the additive manufacturing process. Or you start with your designing, which is more optimal for the additive manufacturing. So you have the conventional way and do the quality check, the healing, the positioning, the nesting and optimization of the geometry to get printed. And therefore you need to find a way to search models which is optimal for 3D printing, right? So therefore, there are a tool on the market from our side, the 3D Part Finder, to identify conventional built parts, for the additive manufacturing based on attributes and so on. And this is what the topic Part Finder will be the main topic for the next webinar. So please notice this on the 28th of April, so nearly in 1 month. So there we will present you the in this next webinar the 3D Part Finder, and for the next step of pre-processing for the additive. So this software for today, what we will present you is then for the next step. So you see here now directly that from the conventional building of the parts or in the designing department until 3D printing, all steps will be covered by the Part Finder and additive software. And the most beneficial point for you is that in the entire workflow until exporting to STL, 3MF, and AMF formats, we work always on exact BREP geometry. So that means we read CATIA files, NX files, SolidWorks, Inventor, STEP, the most common cut formats, and can get a use of all these solids and volume bodies, and we work on them. So that means you have no losses, on the quality. In opposite, you can have a quality check on these BREPs and increase the quality after all operations of positionings, of nesting, optimization, everything. You can then export to tessellated geometries as STL, 3MF, AMF, which is readable for all printer or printer software. So therefore, the goal is the continuous process on exact BREP geometry and export of slicing in vector graphics, so that you are always able to use exact information. So for the additive is a modular based, easy to use software for cut data preparation. So that means we work on precise BREP geometry and keep always the CAD engineering standard. So just a quick overview before we get to the live demonstration of Laurent. So the software can read and heal all major cut formats. And we do have real-time surface quality analysis. We do have massive zone and wall thickness analysis. direct modeling tools and also simplification tools to make hollowing and to do lattice structures inside of the model to keep the strength. But Laurent will inform you and present you with his expertise about all these use cases. Texturing, a unique texturing tool here in this software, support generation, slicing, and hatching functions, and the automatic 2D and 3D nesting. The complete batch nesting software, as mentioned, will be presented in the next webinar. So now I would like to give my word to Laurent and stop shortly sharing, and he will share his screen. Because in this time we are sitting in different areas, and therefore we will just wait. So.
Okay, I hope everyone can see my screen.
So I can see your screen.
Please
Yes.
let us know.
Let me check in the chat.
All right. I'll give you overview about our key functions because I won't be able to show you everything. So I'll start with our graphical user interface. So typically you will start with the machine database. So you will first, or the user will first choose his machines he is using on his shop floor. So we have a quite big database with different machine types. You can filter by different manufacturers, different technologies, also different material families. What we use on our side, because we created a small company, 3D printing company, where we can also test all our software functions in reality. So we own an HP multi-jet fusion printer to test, especially, for example, our 3D nesting tool. So this would be the machine I'm going to choose for today. Yeah, then on the left side, Explorer to search for the files, favorites, where you see your recent files. You can define different folders as favorites. I'm just going to open a CATIA part. And show you a bit how the software is structured. So what we focused on is to have a really simple to use software and not too many buttons, too many windows opening. So the software is organized in different workshops, in different modules. You see here at the top bar. And these workshops follow the AM workflow. So typically you would start with the first workshop, which is called healing. So you would first check your models if there are any geometry errors inside and then repair them. So be sure that the model, the 3D model you want to print is in perfect conditions and there are no holes inside, so that you have a really watertight model, as we call it in 3D printing, to be sure that there will be no errors later in the AM process. Then the next step would be modeling. So you can analyze your file and also adjust it a little bit. Just to mention here on the left side, what opened up when I loaded the model is you have your machine information, the build volume, the material you are using, standard or default tessellation parameters, because like you heard in the introduction, at the moment we still have to export in a tessellated format at the end of the process. So we tessellate the files and export them in STL, 3MF, AMF, OBJ. So this is the default parameters you can set up in your machine to have the accuracy you need for the printing process. The tray properties, as soon as you have loaded models, you will see the number of models, your maximum height, the relative printed volume, so the packing density, which is really important for powder bed fusion technologies, for example, and also the mass properties and a list of the models. Okay, so now I'm going to show you some analysis functions we created, which we feel are really important to make sure that the part can be printed properly, which will be, for example, a wall thickness check. I will quickly check the model. So you see here highlighted now on the model in different colors, the different wall thicknesses. I can just click on the surface of the model and see how thick the model is in the different areas. You can also filter. Yeah, so if you want to see just specific wall thicknesses which are critical for the AM technology you want to use, we can also make the model transparent to see a bit better where the critical areas can be. So this is really important check to know if the file was correctly designed for the technology you want to apply. Okay, the second one, which is also really interesting and which is really important for technologies such as metal printing, but also powder bed fusion technologies in plastics, is our massive zone detection. So this basically detects areas where you have a lot of material which has to be fused together. So you see here on the part these big areas. I can also click on the surface and see the distance to this heat zone is where a lot of material has to be fused together. And this can cause problems during the printing process. So there it is really important to be aware of these zones to either adapt your nesting strategy or to decide, okay, I want to redesign this part and, for example, to hollow it in this area and, for example, to put lattice structures inside, which leads to another functionality in the modeling workshop, which is called hollowing. So I can hollow the part. Here in the configuration, I can change the thickness of my part. I want to have the outer contour. So I will say, for example, 4 millimeters because it's a quite bigger part. And then I can choose between different kinds of lattice structures. For this case, I will use the honeycomb structure. Just quickly adapt the thickness of it and the cell size, and then run the function. So this is also a really good function to have a quick redesign of the parts according to the analysis which we just made, and then to be able to get rid of these temperature heat problems. But at the same time, you're also saving material, because now I will show you when I cut through the model is that here we have now honeycomb structures inside the part. Yeah, and this is what makes us save material. And then afterwards, you can also here on the right side, yeah, this function create plug. You can also create plugs to, for example, if you're using a powder bed technology or also resin technology, you have to make sure that you will get these extra material out of the part, and therefore we can create plugs to create little holes inside the part to be able to to get rid of the extra powder. Yeah, so as you see, the display of the parts changed to the tessellation. I'm just going to explain to you a bit how our software is organized. So we have 2 layers where we can store different information. So what you saw at the beginning was the exact representation of the part. So this is a step file, yes. So you see all the exact representation, so all the faces that describe this model. For some functions like what I just did, the hollowing, the lattice structures, also texturing, we have to change, or we have to create the result in a tessellation. And therefore, we created 2 layers where we can store these information separately. So when I cut through this model here, you see no lattice structures. Yeah, it's just the BREP, the original file. And here on the bottom corner, I can switch between the original representation and the tessellation. And when I change to the tessellation, you see the honeycomb structures inside. So this is a big advantage because now I created this really heavy and complex geometry in the tessellation layer, but I can just continue to work on my BREP and then do, for example, define the orientation of my part, do a 3D nesting, and I will still have a really lightweight model instead of carrying all these complex information throughout the whole process. So we can always switch between these 2 layers, between these 2 representations, which makes the software really performant. Okay, in this, I won't show you everything, just mention it. We have direct modeling tools, offsetting tools. For example, you can adjust diameters of the hole. You can create an offset on a face if the part has to be, if you want to mill, for example, the parts afterwards. We have defeaturing tools. You can delete some rounds and fillets and recreate new ones. I will load another model to show you our orientation analysis. So we have different kinds of, I will quickly check. Sorry for that. I just wanted to know if anybody had a question about what we just saw. So in the orientation workshop, we have some really helpful tools to help you to find the best printing orientation of your part. I will quickly show you how the positioning works. So we have here a center of gravitation where we can move the part, different arrows to move it and to rotate it. You can also type in a certain angle, how to rotate the part, which is what is really helpful if you are using BREP data is you can just select a face, for example, of the part and then position it parallel to the side of the machine to find a good first positioning, because sometimes it can be really complex to rotate around all 3 axes and to find a good orientation. This is a quick way to position it. Then we have different analysis tools, like I mentioned. So, for example, support roughness. It shows you, according to the angle you define, all the areas where, if you're using technology that needs support structures, where you would need these support structures, here in red. And also in green, the areas that have to host support in order to be able to support the faces that need it. And which is quite good also is that you can just at the same time in the analysis mode just change the orientation of the part, and you see in real time how the faces change. Okay, and then what is also really important for additive manufacturing is that every technology relies on the same basic principle, is that we apply different layers of material. So everybody knows this effect. It's called the stair-stepping effect. What you see here is, according to the technology, we have a certain height of layer, which is 80 microns for the HP technology. And so we can analyze this stair-stepping effect, which will be critical on faces that are really flat, and which will be way better on faces which will be positioned vertically. So you can also analyze the stair-stepping effect on the part, and also this in real time. So for example, we see here that the top surface is now red. So really, we have a really flat angle, so big stair-stepping effect. And as soon as I change it to a more vertical position, the effect decreases. So this is also really helpful tool to find the right printing orientation of your part. And the third one we have is a roughness. We can calculate on the part according to experimentations that have been made by universities. So we have an average roughness according to the angle of the surface, how it is positioned inside the machine. Yeah, so these three analyses, according to the technology you're using, help you to find a good orientation of the part. We also have a support workshop to create different kinds of support structures, especially for metal printing. And like we have different kind of support structures: cone, cross, cylinder, parallelepiped, and projection, which would be for material jetting more. And also we can also create tree structures, which are quite helpful either for metal printing or also for resin plastic technologies. I won't show that in detail because we will now focus more on our 3D nesting function, and later I will show you at the end our texturing tool. So for the nesting, I will load some models. Yeah, so you see here different kinds of models: step files, CATIA part, XT. Yeah, so there are no limitations in the CAD files you want to use, to make sure that you don't have to convert into a tessellation, which really decreases the quality of your part. Okay, wait a second for the parts to load. Okay, so we see here I will throw that one out. So all the parts are positioned next to the machine. Either you have pre-positioned the parts, or you can also do it right now if you want to find orientation of a part. Like I mentioned, you can use the analysis tools, which is also quite handy to use, are the different viewings to change the positioning of a part. Okay, and then I will use a function to sort out the model. Either I can pre-position some models because I want them in a certain area of the machine, or I just run the nesting algorithm and set up the parameters for the parts. So the first function would be the duplication of models. If I have certain models I want to print in more than once, you can use these arrows to duplicate it, or just type in a number of duplication. I will now just quickly duplicate these ones. To show you the nesting algorithm. Okay. So here, our nesting algorithm, the function which we call pack, we can set up different parameters. So packing 3D, it also works in 2D, for example, for SLA technology or metal printing, where you can't put the parts above each other. I will show you the 3D nesting for powder bed fusion technologies. We define where the algorithm starts the packing. In most cases, we would use the center. We can define different rotation degrees of freedom for the parts. What I can't show you in this version is now I'm setting up global parameters, but we will launch a new version hopefully during the next months, where you can set up all the parameters for each part. So you will really be able to define for a part how big the distances will be to the other parts, which kind of rotations you allow for the part. So really for each part individually. So now I will just set up global parameters. I will allow only Z rotation because I've already orientated my parts. I find a good printing orientation, a starting position, the current position, a minimum distance of 4 millimeters between the parts. We can then set up some more parameters like a maximum height if you don't want to fill all the whole machine. And yeah, so now I will run the algorithm and you will see how this works. So we first have to voxelize the models and then the algorithm starts. So first of all, the bigger parts are placed into the machine before using the smaller parts to fill up the little holes that remain, and to make sure that we have a really high packing density. So now you see that we've already placed all the big parts. We're filling up here with these little ones and really using all the space to have a good packing density. Okay, so now we already finished with the nesting. There are some additional functions like building cages, so we can create small cages for smaller parts, because as you know, after a printing process with powder bed fusion, you have to sandblast the parts. So it's really helpful to have really tiny, small parts inside a cage to be able to handle them better in the sandblasting process. We can define non-manufacturing areas if there are any areas where you don't want to place parts. For example, in some machines there are sensors placed in the build volume, or the user knows that there are some code areas in the machine where he doesn't want to place parts. You can define these areas. We have a collision detection if the placement of the parts is done manually. Yeah, so this is it about the 3D nesting. And now I will show you to end the texturing. Maybe do it a bit faster because it's already 10 past 11. Okay, so in the texturing tool, we can use, as we said, the VREP representation, so we can really quickly and easily define the areas where we want to place textures. So I will define the zones now. You see here, you can just select really quickly the faces where you want to put the texture. You can also select one face and select all the tangent faces that are attached to this face. And then create the texture zone. There you see then a preview, like a checkerboard, if the projection was done all right. We also have a second projection type, which is called ribbon mapping. We can set here up in the configuration, which really works well for freeform surface and cylindric faces. And then the next step, first step, defining the texture zone. Second step, choosing the texture you want to use. Therefore, we work together with Substance, which is software which is located in the video games and virtual reality sector, actually. They got bought by Adobe, and we integrated their library, so we can use all these different textures. There are a lot of different ones. If you click here on download, you get directly to their website, and I hope this works now. Just to give you a quick overview, there are really a lot of different types of material, texture types. So they have over 5,000 textures, and we can all integrate these into our software because yeah, we have a partnership with them together, and this gives you big freedom in design. Later, I will switch back to the website. I don't know why it takes so long to load. I'm just going to show you how to put a texture. So we can just select a texture here in the library, and you see here all the parameters. So these textures are parametric. It's not just the picture that is applied on the part. You can change the resolution, for example. Then you see way better the leather structure. You can define these stitches, how long they are, how the width of the stitches, if you want 1 stitch, 2 stitches. So this is really parametric. You can change all the different parameters, apply to the part. Then you see a rendered image, which we put on the part. We can then manipulate it, so we can make different adjustments, zoom in, rotate it, and position it well on the part. And then the last step is just to generate the printing tessellation. So you see here the original present tessellation of the part without texture. And now I'm going to recalculate the tessellation based on the texture I just applied. And this will then be the model we can export into 3MF, AMF, whatsoever. Okay. So you see here, this is the result with these stitches, yeah, created in tessellation. And this is then the result we can print out. We can also maybe later show you some pictures of 3D printed parts with textures. We also have them in our presentation. And yeah, you have really a lot of possibilities here to really quickly and easily apply textures on your parts. It's divided in yeah, 3 basic steps. What you can also use, you don't have to use especially only the substance library. You can also use your own textures. So, for example, apply a logo of your company. You can also create a text where you can adapt the font of the text. Yeah, you can label the parts. So we also created a tool where you can automatically label the parts. For example, if the part was duplicated, we can just count these parts so that the quality of the parts can be tracked afterwards. So then you know exactly which part was in which area of the machine. And yeah, these textures also work pretty well. It's just a PNG file or JPEG file, just an image file of these little texture patterns, which are accessible for free or for small money. So yeah, you can also use your own textures in the software. Okay, unfortunately, I don't know why I can't show you the Substance website, but yeah, you can just check it out on your own and see the different possibilities. Okay, that was quick overview from my side of what our software can do. There's still a lot more to show, but we want to focus on our key functions. And yeah, feel free to ask any questions.
Yeah, thank you very much, Laura. That gave us a big picture of the software. I change back to my screen. So you have shown us, yeah, really detailed presentation of our software. So with a lot of options, and so we are always keen to get information based on feedbacks of customers, of prospective customers, to improve continuously our software. So all the ideas, we get from customers. So so it is always a pleasure to talk with you. So let me give you just the information that if you want also to have this PDF file, so we are glad to send you this information here, because here in this PDF, I would like not to go in detail here about all these functions, what Laurent already mentioned before. So these are summaries of all these functions, what we here heard already in this software about massive zones, quality, cutting of large models, direct modeling tools, hollowing, texturing, and some examples of textures, support generation, hatching and slicing, and automatic nesting tools for 2D and 3D. And just a quick information for you that if you don't have a possibility to print with the HP multi-jet fusion printer, we offer also a service for you. So if you have a file, you would like to have it printed in several amounts, so this is possible from our side, based on our subsidiary and let me say like company Additive Innovation. Here, quite close to this headquarter, and you are always free to request to us or to our company. So we come nearly to the end of this webinar. So just a quick summary that we are keeping the CAD engineering standard based on the geometries, on the quality of geometries for optimal printing, through this workflow of additive manufacturing. You have a possibility to make a quick analysis of your geometries, so directly from your CAD files, and do automatic positionings and nesting based on options what you can set up in advance to make it much more easy for you as an user, and unique design possibilities for sure, with the unique texturing possibility, which is based on BREP first, to choose your faces, to choose your texturing, which is really great for interiors and designings, and the batch identification, which will be shown in the next webinar,